Alright, in this video I'm going to discuss how to do the toy car challenge. This is basically if you did not receive the points during the toy car challenge, what I want you to do is take notes during this video and specifically concentrate on figuring out what you were not doing correct. Find the mistake that you made while you were working on the lab. So if you take notes, show me the notes and clearly explain to me what mistake you were making in your math or your thinking, then I will give you the 2 points that other students earned for crashing their cars in the target. So here we are. This is the data I just kind of made up here. I've got a red car that's starting at the origin, 0 meters, and the blue car is starting at 6 meters. You only had 4 meters to work with, so the blue car is starting pretty far to the right. Now here's some other data you had, and I saw that some students were sort of confusing this data as well. The red car traveled 4 meters in 26 seconds, and the blue car travels 4 meters in 15 seconds. This data we use to find the velocity of the red car and the velocity of the blue car. Now in terms of velocity, just for velocity right now, we're going to check the absolute value of velocity, so we could just call that speed. So what I'm going to do is I know that velocity equals distance over time. And I have a distance and I have a time. So let's say velocity of the red car, say v sub red, equals whatever distance I had, 4 meters divided by 26 seconds, right? So I put that in my calculator, and I get 0.15 meters per second. And that was a slow car, so that makes sense. It's quite slow. And now let's say velocity v sub blue, the velocity of the blue car. That is going to equal the distance, 4 meters, divided by 15 seconds, which equals 4 divided by 15. And that gets me 0.2, say 7 meters per second. Okay? So I've got my velocities. My v sub red, the velocity of the red car is 0.15 meters per second. Blue car is 0.27 meters per second, which might seem slow. However, we're talking about meters per second. These are little toy cars, so that's pretty good. So now these are my 2 velocities, right? And now I have to figure out, well, what's going to happen here? So I'm going to draw a little picture, okay? And we'll say there's my 0, let's see, 6 meters. So let's do, yeah, this is fine. 1, 2, 3, 4, 5, 6 meters. These are all meters, so we'll say, draw a little number line, and this is x in meters, we'll call that. Okay, so there's what the number line is. Now my red car is starting at the 0 mark. So there's my red car. It's going to be going this way, right? That's the way the red car is moving. That's the positive direction. The blue car is starting way over here at the 6 meter mark. And it's going to be going that way, in the negative direction. So that means, if I look back to their v sub red, it's going to be positive 15, and v sub blue is actually going to be negative 0.27 meters per second. That's very important, and a lot of people missed that, but this was a common mistake as well. Remember, your job also, besides taking notes, is to figure out what mistake you were making during the lab. So now, what's going to happen here is I'm going to make an equation, a line equation for both of these cars. And it's going to be reflected, it's going to be like a line equation of one of these graphs where you have position in meters over time in seconds, right? The red car, and sorry I don't have colored pens here, but the red car is going to be going slower and in the forward direction. So I'm going to make like a kind of a shallow, not a very steep slope line. The blue car is going to start at a higher position and go quicker Those look kind of the same speed, so that's just kind of weak. But anyway, whatever. That should be a steeper line because the blue car is going faster, but it doesn't really matter. The point is, I'm interested in finding this spot. Where do they meet? Where do these two cars meet? So I'm just going to make an equation for both lines. I'm going to figure out where they meet. That's what the plan is. So let's start with blue. We'll just start, red up here. We'll start with red. Red line, we'll call it, all right? My red line equation. Well, we know that a line equation generically is y equals mx plus b, right? So I've got, and remember that my y-axis is my x position because the car was traveling along the ground. So my red line equation is x, my position in meters, equals a slope. And the slope of this line is the velocity because it's position over time. And velocity is distance over time. So what is the slope of the red? It's 0.15 meters per second times a time. Now, one thing some students do is they took this time and plugged it in for t. Well, don't do that because I'm not talking about this time. This was me testing to see how far, this was us just testing velocity in front of the class. We went the whole 4 meters and timed how long it took. In this scenario, I'm going to aim them at each other and figure out where they meet. So it's different. I have an unknown time. Okay? And then it's going to be plus b, right? But we know that the red car starts at the origin, so I don't have an intercept for the red car. So this is my equation for the red car line. X equals 0.15 meters per second times time. That's it. Let's do the blue line. The blue line is x equals, again, in meters, position in position, right? Where are they gonna, where they would meet, equals the slope of the blue car, which is negative 0.27 meters per second, times some unknown time, plus the intercept of blue, which is where blue started, which is on 6 meters, plus 6 meters. You'll notice that it's important to keep your time as a little curly QT so it doesn't look like a plus sign. All right, so now the only way I can figure these two equations out, if I say they are going to meet at the same spot, right? Where they crash is the same spot. That makes sense. Like if you crash into someone, you're at the same place. So I'm going to set the position equal to each other. And so I'll just say 0.15 meters per second times time is equal to, that's this right here, right, is equal to this one. Is equal to the blue, where the blue is. Negative 0.27 meters per second times time plus 6 meters. Solving for, I'm gonna pull this t over here by adding it, right? So, I'm going to say, well, what is 0.15 plus 27? Because I'm adding that over. So 0.15 plus, that didn't work. 0.15 plus, that's bad news. 0.15 plus 0.27 equals, so now I have 0.42 times time is equal to 6 meters. So I just divide out the 0.42, and now I'm left with time equals 6 divided by 0.42. Time equals 14 point, we'll just call that 14.3 seconds. So there is my time, but that's not a distance yet. In order to get distance, I just need to plug it into one of these equations. This one's easy, right? Plug it in here, right? If I plug the t in this time, that'll get me the distance, where it's at. So I'm going to say x in meters equals 0.15 meters per second time, this time that I calculated, times 14.3 seconds. So then I do this 14.3 seconds times, oh gee whiz, this calculator is terrible. So 0.15 times 14.3, I'm left with x in meters equals 2.115, whatever, meters. So there's where they would meet. That's where I would put the target in the lab. I would put the red car at the origin, I put the blue car facing the red car over the 6-meter thing, and they would meet at 2.5 meters. So these cars are going to meet somewhere around here. Does that make sense? Well, I know that the red car is slower than the blue car, and they're going to meet closer to the red car. That makes sense to me. So again, show me your notes from this video. Here's the entire page if you want it. The answer, by the way, is right here. Show me your notes from this video and tell me exactly, clearly spell out exactly what you did wrong. And I will give you the 2 points that you did not earn during the toy car challenge.